between two curves. Now let's think about this. We have two curves, so we need to know which curve is higher. Like this at the moment, the blue one is down here. And if we're finding the area between two curves, and let's say x equals 0, or in this case x equals a and x equals b, we're finding this area here. Okay, just that blue part there. If we now finding the area under the curve of this red one, we're finding all that right up to there as well. So you can see this part here has been doubled over. Okay, so that's not what we want. If we are finding the area between the two curves, we want this green part right here. Okay, so how do we find that one? Well, we take this whole area and we subtract this section over here. Hang on a second, guys, I need to do something. You can't shut my door. Okay, sorry about that. So that's how we end up getting that. So it's going to be this whole area under this red curve minus the area under the blue curve to give us this area between the curves. So that's what this is saying. There's my f of x, the red one, minus the blue one, which is the same as just working that out. Okay, because you don't have to work them out separate. You can work them out as one. Any questions there? Okay, so I'm just going to clear this one. Actually, I'll wait a minute in case someone wants to write that down. Okay, I'll clear this. Okay, example 17. Go back to my blue pen. All right, this is 11I question 1, and it says, find the exact area of the region bounded by the graphs of y equals 12 minus x squared and y equals x plus 1. So you need to sort of have in your mind or sketch it very quickly what these graphs looks like. So we know that this is an inverted parabola, so I've quickly sketched them. We know that that is 3, 0 and negative 4, 0. And we know that this is a straight line, and we can quickly sketch that. It's only to determine, okay, which graph is on top. In this case, we can see that the parabola is on top. Okay, so when we do this, and it only says bounded by those regions, so we need to know where they intersect, okay, because that's the area bounded by the two curves, okay. So this one intersects at negative 4, 0, and this intersects at 2, 6. If you don't have your calculator, because they don't make you use your calculator, you would need to work those intersection points out. And we know how to work them out. We're just going to equate and then solve. Okay, so we found that they intersect at negative 4 and 2. So there they are there. My limits are negative 4 and 2. Because the blue, the parabola, is on top, I've written that first, 12 minus x squared. And I'm going to take away, because remember that finds that whole area, and I'm going to take this area away. So I've taken away the straight line of x plus 4. Any questions there? Okay, of course you've got to, you know, help yourselves out here. I've taken away, so I've got minus x minus 4 because I expanded that, and I've simplified, and we got down to 8 minus 2x minus x squared. Now I've got to integrate this, so integral of 8 is 8x. The integral of negative 2x is negative x squared, and the integral of negative x squared is x cubed divided by 3 between negative 4 and 2. Any questions up to here? Okay, substitute x equals 2 first, always the top one. So put the 2 in, 8 times 2, 16, minus 2 squared, 4, minus 2 cubed, 8 divided by 3. And of course we subtract. Now I'm going to substitute the negative 4 in. 8 times the negative 4, negative 32. Negative 4 squared is 16, but there's a minus there, so minus 16. Negative 4 cubed is a positive 64, and a negative, It's a negative, but negative makes it a positive. So we've got 64 on 3, and we simplify it, which we end up getting 36 square units. Any questions on this one here?
How did we get the, like, you know how like it's like cut in half, like diagonally? How do we get rid of that bottom half again?
Diagonally, which one are we talking about?
You know where x plus 4 cuts through the graph in that,
Yep.
like the below section?
Yep.
How do we get rid of that?
This section here?
Yeah.
How do we get rid of that? We're taking it away.
Yep.
So we're finding this. I'll just clear this and I'll show you again. We're finding this. The blue graph finds this.
Yep.
All that area. Okay? But we are subtracting this part here. There it is there. Minus the x plus 4, the area under this graph. That's why we're minusing it. Okay? Which gives us only this area over here between the two graphs.
All right.
Okay? That's why we minus. Any other questions?
Cool.
Okay, let me clear it and I'll move on. Not quite sure why that's moved up, but this is question 7. Now, question 7 from your book, I think already had the graph, so there it was there. Okay. Okay, annotate. I'll go back to my blue one. All right. And this one says find the area. Okay, so if we look at this, we've got the red one from here to here on top first. So we're going to we have to break this up. Okay, so I'm doing the cos x first, which is the red, there it is, and I'm minusing the blue one, which is, of course, this section here. And there it is there, which is sine 2x. But then on this half, I've got to do the opposite. The blue is first. So I've got my sine 2x and I'm minusing my red graph, which is the cos x. Any questions there? I've got my limits. The first one from 0 to pi on 6, there it is. And the second one from pi on 6 to pi on 2. And there they are. So you've got to make sure your limits are correct. Now we need to remember how to integrate. So integration of cos. When we integrate cos, we just get positive sine x. When we integrate sine, okay, but sine has a 2x. So we first have to differentiate in here. When I differentiate in there, I get 2. So I get 1 divided by that derivative. So 1 divided by 2, and now we've got to do sine. Integrate sine is negative cos of the 2x. So that's how I get a negative and a negative becoming the positive. And I've got my half cos 2x. Any questions there? Okay, the limits is between 0 and pi and 6. Then I'm doing this one here. Well, this is the same. Integrate sine. Okay, first we've got to differentiate this part, which is a half. Integrate sine is the negative. I've still got my cos 2x. And now my cos. Integrating cos, you know, is a negative. Differentiate sine. No, integrating sine. What have I done there? Integrating cos. Integrating cos should be a positive. How did I get that one there? That should be minus. Unless I've made a mistake somewhere. Can anyone see it? Differentiate sine, you get probably. Oh, I don't know. I must be right. Yeah, it must be right because I think is my answer right? Should be right. You know, we'll keep going. Okay, put in the pi and 6 in here. Put in the 0 in. So that's how we get these parts. And then put in the pi on 2 and put in the pi on 6. And you have to work it out. You actually have to know your exact sine, cos, tan for the radians, 30, 60, 90 degrees, 45 degrees. Either that or you've got to remember the triangles and you've got to write them down. Now, for those of you who need to remember the triangles, I'll quickly write them down here. First one's a right angle triangle, 45 degrees for both. 1 square root of 2. The second one is an equilateral. I'm only doing that as a dotted. This one's a solid and this one is dotted because they're all 60 degrees. This equilateral is going to be cut in half and they're all side length of 2. So this is now 1. Of course, when I cut a 60 degrees, it becomes 30 degrees. And then I can work this out as the square root of 3 because that's 1 and 2 there. So you're just going to have to remember them. But any questions on this one here? Okay, let me clear this one. And that's 11I. So I'm going to stop here today. That's 2 exercises I have done. I'll stop here. I know that Neha, you sent me some questions. I've worked out